You are welcome to our online teaching series. And our today's topic is resolution of vector. Last class we talked about resultant of vector, where we we find a way of combining two vectors to form one, which we call the resultant, which have the same effect as those two vectors. But the opposite of resultant is what we call resolution of vectors. Resolution of vectors simply mean we are going to convert only one vector into two perpendicular vectors that have the same effect as that particular one vector, that is as the original vector, which means resultant involves turning two vectors to form one, while resolution involves turning one vector to form two perpendicular vectors. Now, take for instance, we have vector R or vector R acting at a point O. Vector R is neither on y-axis nor on x-axis. We should know that we can trace a y-axis and we can trace a x-axis. But if you look at our vector R, it doesn't belong to any of the two axes. It's just on its own. It's different from vector Q. Vector Q, which is already on what? On a negative y-axis. This one is already on negative y-axis. So therefore, we don't need to resolve this. But for this, there is need for us to resolve vector R because it doesn't belong to any of the two axes. And that is why we need to know what is the effect of this vector R on vertical axis, that is the y-axis. On the vertical axis, we will trace it. If we know that the angle is theta, let's say the angle is theta. If I have the angle to be theta, I can trace it to form the y-axis, which I call the ry. You see, this is for y, vertical, ry. Then we can also have the rx. That is the effect of vector R on x-axis. These our rx and ry, they are known as the components of vector R. The component of vector R on y-axis, on vertical axis, is ry, while the component of vector R on horizontal axis, that is on the x-axis, I call it rx. We have already formed a right-angled triangle in which we can know both our ry and our ry and our rx respectively. Of course, we can also know what this angle what this angle can form. Let's see. If we have sine theta, according to our last topic, we talked about secant. Sine theta is what? Opposite all over hypotenuse. Now, which means what is our opposite? Our opposite for theta is ry. Ry all over hypotenuse is your vector R. And that will give us, if you cross multiply, you can easily know that the ry is equal to r sine theta. Remember, it is not always that your ry will be what? R sine theta. I told you the other day, it depends on where your angle belongs. Right? If your angle falls here, then it means this will be the opposite, which means rx will be the one that will be carrying sine theta. Now, alternatively, or let's say similarly, if we have cos theta, we have adjacent all over hypotenuse. The adjacent of this theta is rx all over r hypotenuse. If you cross multiply, you get your rx is equal to r cos theta. You see? So which means the component of the component of vector R on x-axis is r cos theta, while the component of vector R on y-axis is r sin theta. Make sure that whenever you are solving this, always remember to note where your angle belongs. That is where your angle falls. If your angle falls here, this will be the opposite, which means you will have rs to be r sin theta in that case. If your angle is here, it means this place will not be r sin theta again, it will just be r cos theta because it will become the adjacent. Okay, again, we can easily determine the angle we are talking about if it is not given. But most of the case will be given angles. Secondly, you must also know the direction. What direction is your RX going? What direction is my RY going? Let's redraw the vector again here. Vector R. This is vector R. You have to know the origin and the termination. That is the origin and the end of our vector. The origin is this place and the end is this place. So we must trace another vector that travel along the same direction. That is an end up there. So which means this is our Rx, this is our Ry. That is a vector that starts from this origin in horizontal axis and move towards the vertical axis so that to enclose this vector R, which means this is our Ry, this is our Rx. Consider a situation whereby, don't forget that your theta still remain here. So which means your Rx is Rx, your Ry is Ry, which is r sin theta and r cos theta respectively. Consider another vector Q. Consider another vector Q. Consider another vector Q. Let's say another vector, another vector Z. Another vector Z. When let's say this is vector Z. Vector Z also have its own x and y axis, though it doesn't belong to any of them. Y axis, x axis. So let's say we have vector Z making this vector Z, forming an angle alpha with our y axis. You can easily see, let's see what will happen. I can trace, for us to trace any vector that we start from the origin and enclose this place. Start from the origin and enclose. What will happen? You will have something like this. This vector Z. This vector Z. You have to start from origin O and you want to end here, which means you have to trace it down vertically. That is, trace it down vertically. This is your vertical axis, and trace it this way horizontally so that it will go and meet the end of vector Z. You see this vector Z, this vector Z, vector Z, vector Z in the same direction. The same direction. So this is the vertical component of vector Z, which we know as y axis of vector Z. And this is the horizontal x axis, that is x of vector Z. This time around, the angle alpha will be here, angle alpha. So what I want you to note here is that your zy will not more be positive, but it will now be negative. I hope you know why. Because this is origin. Everything from here up is positive. From here down is negative for y axis. The same thing happened to your zx. Moving from here, going to the right is positive. But assuming it is going to the left, it's going to be negative. So that is what you should also observe. Now let's see. Assuming I want to find zy now. I want to find this. I will just say sine alpha is equal to the opposite of alpha is my zx this time around. The opposite of alpha is zx all over. The adjacent of alpha, the hypotenuse is capital Z. Cross multiply, you get your zx equals to z sine alpha. Similarly, you can see this one is quite different from what we have initially from the other one, where you have rx to be r cos. But this one zx is z sine alpha. The reason is that it is zx that is opposite to that alpha. You should also, that is what I want you to observe. Secondly, if you want to do the other one, cos alpha is equal to zy all over your z, all over z. Now, this time you should know that your zy is going on negative y axis. Look at it, going negative z axis, and that is why this one will become negative. Therefore, your zy will become minus z cos alpha. I hope you know the reason why we put negative here, because it is a negative, the opposite of a vector. The opposite of a vector will be negative of that vector. So, the opposite of that vector. Now we can then move to resultant of more than two vectors. Resultant of more than two vectors. Resultant of more than two vectors. For us to solve resultant of more than two vectors, we must make use of our resolution of vector, the one we just treated now. Let's assume we're given a vector, see these several vectors, several forces acting on this object O. They said determine the resultant of the system of forces in the figure below. That is, if somebody is pulling these objects with 6 Newton, another person 10 Newton, another person 20 Newton, all of them are applying forces. This one is applying his forces 10 Newton, this one is applying his forces 10 Newton, 2 Newton, 4 Newton. Where will this object here move? Let's assume this is a table, and everybody are trying to pull it to their side. So what will happen? And that is what we mean by resultant. We need to know what is the force that will pull this object. What is that force that will make this object move? Number one. Number two, what direction will it even move? That is another thing we need to know. Now, for us to attend to that question, we must now make use of what we call resolution of vectors. Now, if you look at all the forces we have here, we can see that 8 Newton is already aligned on his y-axis, so we don't need to touch that. It's already resolved. 10 Newton is also aligned. The same thing applicable to 4 Newton is already aligned to x-axis. While other forces like 10 Newton here, which is what? The 10 Newton we have here is making an angle 30 degrees with the horizontal. So we need to resolve this. We need to resolve this 2 Newton, we need to resolve this 6 Newton, we need to resolve this 20 Newton, because they don't belong to any of the axes. Now, that is why the step to take, step number one, the first step to take when doing such thing is resolve each vectors to their various vertical, that is various two vertical components, What I mean by two vertical components, that is their x and y component, as explained earlier. Components. You resolve it to their x and y components. Each of them, you pick them one by one. You resolve it. For example, you pick 6, you resolve it to what? X and y. Pick 10, resolve to x and y. Pick 2, resolve to x and y. Pick 20, resolve to both x and y. But 10 is already on this particular 10. It's already on y, negative y. And the only thing you just do is, you just say it is negative y axis. So it doesn't have any component on x axis. The same thing applicable to 4. Doesn't have any component on y axis. It only has component on x axis. Now, number 2. The second step is that add all x components together. All x components to form a new vector, let's say Rx, which will form the new vector Rx. R implies the resultant vector we are looking for. And thirdly, add all y components to form a new vector ry. And once you do that, you can then determine the overall resultant. You can then determine the overall resultant that we are looking for, which is 4. We can then form a new diagram. Diagram as shown. Let's see. The diagram that we are going to form is that we say we already formed a new vector Rx on vertical component, and we also form another vector Ry on horizontal component. I mean on this vertical, Ry on vertical and Rx on the horizontal component. Then you can look for your what? Your resultant R and the angle that is theta that it formed. You see? Once you do that, this resultant can be found using your Pythagoras theorem. R squared is equal to Rx squared plus Ry squared. You can make your R formula from Pythagoras theorem that we treated. Then you can also find the angle tan theta is equal to opposite Ry all over adjacent Rx. Then you can make your theta the of the formula, and that will be the direction of the resultant.